You're listening to the Bare Metal Cyber Prepcast, created to help you succeed in your Cloud Plus certification journey. Learn more at baremetalcyber.com, where additional prepcasts, books, and training materials await. Let's get started. In cloud computing, input and output virtualization is a critical concept that allows multiple virtual machines to share access to physical devices like network cards. Efficient I/O virtualization improves both performance and scalability across multi-tenant infrastructures. One of the most advanced techniques for doing this is single-root I/O virtualization, or SR-IOV. This technology enables virtual machines to communicate with physical hardware more directly, reducing overhead and latency. For Cloud Plus candidates, SR-IOV is a performance-focused topic that intersects with hardware configuration, virtual machine behavior, and network design. SR-IOV is especially important in high-throughput and low-latency workloads, where traditional software-based switching becomes a bottleneck. Instead of routing network traffic through the hypervisor's software switch, SR-IOV allows network traffic to bypass the hypervisor entirely for certain paths. This direct connection improves packet processing efficiency and allows for better bandwidth utilization. It's a key tool in environments where predictability and throughput are more important than portability or advanced orchestration features. At a basic level, SR-IOV enables a single network interface card to expose multiple virtual interfaces. These interfaces are called virtual functions. A physical function is the base device and retains full configuration capabilities, while each virtual function is a lightweight interface assigned to a specific virtual machine. To the guest operating system, the virtual function appears as a standalone device, offering direct access to networking resources. This is fundamentally different from software-based virtualization, where the hypervisor intermediates every packet. The distinction between physical functions and virtual functions is central to how SR-IOV works. The physical function resides on the network interface card and is visible to the host. It can create, manage, and destroy virtual functions, which are then passed through to virtual machines. Each virtual function has its own queue, memory space, and interrupt mappings. Because virtual functions operate with less hypervisor intervention, they offer better isolation and lower latency for performance-sensitive traffic. Implementing SR-IOV in a virtual environment requires support at multiple layers. First, the physical hardware must include a network adapter that complies with the SR-IOV specification. Second, the system BIOS or UEFI firmware must enable SR-IOV capabilities. Third, the hypervisor must support SR-IOV and expose virtual functions to guest instances. Finally, guest operating systems must include the correct drivers to interact with the assigned virtual function. Without full-stack support, SR-IOV will not function properly. The benefits of SR-IOV are clear in environments where performance consistency is essential. By avoiding software switching, it lowers latency for real-time applications like voice-over IP, financial transaction processing, or high-performance computing. It also reduces the central processing unit overhead typically associated with packet forwarding in virtual networks. In multi-tenant environments, SR-IOV supports better predictability because each virtual function is more isolated and deterministic than shared software switches. Common use cases for SR-IOV include high-performance computing clusters, database backends requiring rapid replication, and network functions virtualization. These workloads benefit from direct hardware access and consistent network behavior under load. SR-IOV also enables certain classes of I/O-intensive workloads to run in the cloud without performance degradation, bridging the gap between traditional bare metal and fully virtualized systems. The Cloud Plus exam may ask candidates to identify which workloads justify the use of SR-IOV. Despite its benefits, SR-IOV does come with limitations. Because virtual machines are directly bound to a hardware resource, They lose some of the portability typically associated with virtualization. Live migration becomes difficult or impossible, and dynamic scaling is limited because virtual functions are tied to the underlying physical device. Monitoring may also be less comprehensive, since traffic bypasses the hypervisor's inspection tools. These trade-offs must be considered carefully during architecture and deployment planning. Traditional virtual switching routes traffic through a virtual switch or bridge within the hypervisor. This allows for complex policy enforcement, visibility, and network service chaining, but adds latency and consumes more host resources. SR-IOV, by contrast, skips the software path and routes directly to the virtual machine. While this reduces overhead and improves performance, it also bypasses certain hooks that administrators rely on for traffic shaping, intrusion detection, or logging. The choice between SR-IOV and virtual switching depends on the needs of the workload. Cloud support for SR-IOV varies across providers and regions. Some cloud platforms offer SR-IOV-enabled instance types specifically for high-performance workloads. These instances are typically more expensive and come with restrictions around feature compatibility. For example, an instance may not support snapshots or resizing while SR-IOV is active. Cloud Plus candidates should understand which platforms offer SR-IOV, how to enable it, and what limitations must be considered during design and deployment. For more cyber-related content and books, please check out cyberauthor.me. Also, there are other prepcasts on cybersecurity and more at baremetalcyber.com. When considering security in SR-IOV deployments, it's important to recognize that direct hardware access changes the traditional trust model. Because traffic bypasses the hypervisor, some of the inspection and control mechanisms usually available to administrators may be unavailable. Isolation between virtual functions must be enforced at the hardware level, typically through the network interface card itself. Improper configuration or hardware vulnerabilities could lead to unauthorized access between tenants. The Cloud Plus exam may ask about these risks and how to mitigate them with trusted hardware and proper separation. Configuring and troubleshooting SR-IOV requires validation at every layer of the stack. Administrators must ensure that SR-IOV is enabled in the BIOS or UEFI settings and that the correct drivers are installed in both the host and the guest operating systems. Incompatible driver versions or missing firmware support will prevent virtual functions from being detected or used. Monitoring tools can verify the status of each virtual function, check error counters, and confirm whether the virtual machine is actively using the assigned resource. Performance benchmarking is critical when deploying SR-IOV for latency-sensitive workloads. Administrators should test throughput, round-trip times, and packet loss before and after enabling SR-IOV to validate its performance benefits. Benchmarks help ensure that the theoretical advantages of bypassing the hypervisor translate into actual gains in production environments. In addition, metrics should be collected over time to verify that performance remains consistent under different traffic conditions or tenant loads. SR-IOV introduces scaling considerations, especially in cloud environments. A single network interface card can only support a limited number of virtual functions, and that limit varies by hardware model. Overallocating virtual functions can cause performance degradation, resource contention, or even system instability. Organizations must plan carefully to ensure that tenant demand does not exceed physical capacity. Some cloud platforms prevent overallocation through quota controls, but the administrator is ultimately responsible for balancing availability and efficiency. Monitoring SR-IOV traffic presents a challenge, as traditional tools that rely on the hypervisor's software switch may not capture all packets. This reduces visibility into flow-level data, which can hinder troubleshooting and compliance auditing. To address this, enhanced monitoring tools or in-guest agents may be needed to collect metrics from within the virtual machine. These tools can provide information on bandwidth usage, error rates, and packet types, helping to close the observability gap. SR-IOV is not compatible with all cloud features. For example, live migration is often disabled for virtual machines using direct device access, as moving the virtual machine between hosts would break the hardware binding. Similarly, snapshotting, cloning, or automated scaling workflows may be limited or unavailable. Administrators must weigh these limitations against the performance benefits and determine whether the workload requires advanced orchestration or just raw speed and reliability. Cloud Plus exam scenarios may include diagrams of virtualized environments where candidates must determine whether SR-IOV is suitable. Questions may focus on whether high-throughput workloads, such as video transcoding or low-latency financial applications, would benefit from SR-IOV. Alternatively, candidates might be asked to troubleshoot configurations where SR-IOV is enabled but underperforming, requiring knowledge of BIOS settings, virtual function allocation, and network interface compatibility. The benefits of SR-IOV extend beyond networking. The same principles are used to virtualize storage and compute interfaces, enabling direct access to solid-state drives or graphics processing units. By reducing the number of software layers between the virtual machine and the physical resource, SR-IOV-based solutions provide consistent, high-performance I/O. This makes it possible to run high-speed analytics, scientific simulations, or media pipelines in cloud environments without the performance penalties of traditional virtualization. Best practices for using SR-IOV in the cloud include targeting it toward specialized workloads that require predictable performance. Not every application needs the speed or low latency that SR-IOV provides, and in some cases, the trade-offs in flexibility or automation are too steep. Organizations should verify hardware and driver compatibility, ensure that guest operating systems are properly configured, and monitor usage continuously to detect performance regressions or security risks. In summary, SR-IOV is a powerful tool in the Cloud Architect's Toolkit, offering near bare-metal performance for select workloads. It reduces latency, increases throughput, and lowers central processing unit overhead by allowing virtual machines to access hardware directly. However, it also introduces complexity in terms of configuration, monitoring, and compatibility. Cloud Plus candidates must understand when and how to use SR-IOV effectively and be able to recognize its benefits and limitations in real-world design scenarios. Thanks for tuning in to the Bare Metal Cyber Prepcast, your trusted source for cybersecurity news and insights. Remember to subscribe at baremetalcyber.com so you never miss an update. And visit cyberauthor.me for best-selling cybersecurity books that equip you with expert knowledge. Until next time, stay secure and stay vigilant.